Today, we're diving into one of the most famous charts in all of science. But I want you to just forget about that boring classroom poster for a minute. Think of this as more of a map or a cheat sheet, maybe even a secret code to how the entire universe works. So let's get into it.
To get started, just think about this massive challenge. Imagine your job was to create a catalog of every single fundamental substance that makes up, well, everything. Our world, the sun, distant galaxies. I mean, where would you even begin?
Well, the answer turns out to be kind of beautiful in its simplicity. You use a table, but this is no ordinary table. This is the periodic table, and it is an absolute masterpiece of science.
So let's start by treating this thing like a map for every kind of matter that exists. And just like with any map, the first thing you have to do is learn what the symbols mean.
The most basic symbols on our map are the elements. An element is just a pure substance made from only one type of atom. You can think of them as the basic ingredients of the universe. Like flour, sugar, and eggs for a cake. Oxygen, carbon, gold. Those are the universe's ingredients.
Okay, so now let's zoom in a little on the individual squares on our map so we can start to learn the language of the elements.
Each and every square stands for one unique element, and it has a 1 or 2 letters symbol. Now there's a simple but very strict rule here. The first letter is always a capital, and if there's a second one, it's always lowercase. So helium is He. Some are super obvious, like O for oxygen, but others are like a little history lesson. Fe for iron comes from its Latin name, ferrum. Kinda cool, right?
This brings up a really good question that a lot of people have. If this table lists all the substances, then where's something like water? I mean, it's everywhere. Take a look. Can you spot H2O?
The answer is you can't, and this is actually a brilliant way to understand a really key point. The periodic table lists only the elements, the basic ingredients. Water, H2O, isn't an ingredient, it's a recipe. It's a compound that you make by combining 2 hydrogen elements and 1 oxygen element. The table gives you the H and the O, but it's up to chemistry to follow the recipe to make H2O.
Now let's zoom back out and look at the whole map. You'll start to see it has a pretty logical geography. Generally speaking, all the metals live over on the left side and in the middle. The non-metals, they're hanging out on the right, and there's this clear zigzag line that separates them. And then there's hydrogen. Hydrogen's kind of the rebel. It's a non-metal, but it's so unique, it often gets its own special spot.
But the layout, it's so much more than just a list. There's a hidden logic to it, a secret code built right into the grid itself. And when you understand this, you unlock the table's real power.
The first part of the code is in the rows. We call them periods. And as you read across a period, from left to right, like you're reading a book, the elements are just lined up in order of their atomic number. Simple enough, right?
But the columns. The columns. These vertical columns are called groups. And this right here is where the real genius of the table is. This is where the magic happens.
So here's the big secret. Every element in the same vertical column is basically like a family member. They might look a little different, but they act in very, very similar ways. They share all these chemical and physical properties, and this similar behavior, it keeps popping up at these regular, periodic intervals as you go down the list of elements. And that's it. That's why it's called the periodic table.
Now, this whole family organization thing isn't just to keep things tidy. It gives the table an incredible, almost magical power. The power of prediction. Let me show you what I mean.
Let's just look at the family in Group 1. This table here shows their melting points. So at the top, you've got lithium. It melts at 180 degrees Celsius. Go down one step, sodium melts at 98. Go down again, potassium's at 63. Are you seeing the pattern here? As you move down the column, the melting point just keeps on dropping.
Okay, so now it's your turn to be the scientist. The very next element down in this family is francium. So based on the pattern you just saw, what's your prediction? Is its melting point going to be higher or lower than cesium's 28 degrees?
That little prediction you just made in your head? Well, that's called a hypothesis. It's not some wild guess. It's an educated prediction you made based on the evidence on the pattern right in front of you. See? You just did science.
And if you predicted that the melting point would be even lower, you are absolutely right. The pattern holds true. This right here is the true power of the periodic table. It doesn't just describe the elements we already know, it lets us make incredibly accurate predictions about them.
Okay,
So let's zoom out one last time and really put it all together. Why is this grid of boxes so important? Why is it considered one of the cornerstones of science?
Because it's the ultimate cheat sheet. It takes every single fundamental ingredient of the cosmos and arranges it in a way that just reveals these deep, amazing patterns. It lets us understand how elements are going to behave, and it even helps us predict the properties of elements we haven't even found yet. It is, without a doubt, one of the most powerful and just elegant tools we've ever created.
So the next time you see the periodic table, don't just see it chart. See it for what it is, a map of the known universe, a map that we're still filling in. And that leaves us with one final, pretty exciting question. What new discoveries are waiting for us, just beyond its edges?